Okay, welcome to the final section in this chapter, and it's definitely the most difficult, so if at any point you need to pause it, rewind and listen to it again, please feel free to do so. Okay, so the topic is called frustums, and what is a frustum first of all? Well, a frustum is when we take a cone and we take a slice out of that cone and we're left with the section at the bottom. So there's my frustum. So how would you find out the volume of this shape? Well, we know that the volume of it is equal to the big cone minus the small cone. So the volume of a frustum is equal to the volume of the big cone minus the volume of the small cone. Now you have to remember this formula, but we'll keep it up at the top there for now. And now we're going to try and apply it to a question, but there's quite a lot of work we have to do in this, so pay attention really carefully to what we're doing at each stage of the process. Now here is our frustum, and at the moment we only know that the area of the circle at the top is 4, the circle at the bottom is 10, and the height between them is 3. So we need to try and think about what is our large cone and small cone going to look like. Now to do that, I'm going to draw in these lines here so we can see this is a cross section now of what the large cone and the small cone would look like. And let's bring this one up here so we take a separate look at it. So let's annotate this now to see what information we do know. And we know that this length here is 10, that's the radius of my bottom circle, so imagine a circle around there, and this length here is 4, okay, that's the volume of the smaller circle and the base of the small cone. This length here is 3, and we're trying to find out the height of the large cone and of the small cone. So we're going to call that h for the time being. Now with similar triangles, I always think it's easier to then split that into two other triangles. So there's my big triangle, they're not perfect, and there's my small triangle. And we know that this length here is 10. This length here must be h plus 3, and this length here is 4, and this length here must be h. So to find out h, using our theories of similar triangles, we know that h plus 3 divided by 10 must be equal to h divided by 4, because they've been enlarged by exactly the same proportion. Now cross multiply here to find we get 4h plus 3 is equal to 10h, and expand the bracket to try and solve it, so we get 4h plus 12 is equal to 10h. Now we want to solve this, so let's take away 4h from both sides to find that we get 12 is equal to 6h, and now we're going to divide both sides by 6, and we find that h is equal to 2. So that's the height of my smaller cone. So this area here now is 2. So the height of my larger cone, that will be 5, and the height of my smaller cone will be 2. Now check that. That makes sense because 10 divided by 5 is the same as 4 divided by 2. So they're in exactly the same proportion with that length. So we've got two cones now, and we need to find out the volume of both of them. So let's start with the volume of the large cone. Now use our formula for a large cone, which is that it's 1/3 times the area of the base, so that's pi times 10 squared, times by the height. And our height of the large cone is equal to 5. Put all that into your calculator and you should get 500 over 3 pi centimeters cubed. Now I'm going to leave it in that form for now, I'm not going to round too early. So that's the volume of our large cone. Let's now find the volume of the small cone in exactly the same way, and so that's equal to 1/3 times the area of the base, which is a circle of radius 4, so it's pi 4 squared, times by the height, which is just 2. Put that into your calculator and you should get 32 over 3 pi. So that's my volume of the small cone. And then finally find the volume of the frustum. Oops, let's spell that correctly. That's equal to the volume of the large cone, 500 over 3 pi, minus the volume of the small cone, 32 over 3 pi, and we get exactly, in a calculator, 156 pi, which if you want to evaluate it, is equal to 490.1, and they are both centimeters cubed, because we are talking about volume. So that is your final answer of that. So quick recap on what we did there. We had to first of all try and imagine these cones to be able to work out the height of them. We did that by forming similar triangles, which we got over here. Using our theories of similar triangles, we found that h plus 3 divided by 10 is equal to h divided by 4, Solve that, we find out the height of the small triangle is 2, and therefore the height of the large triangle is 5. From that we were able to then work out the volume of the large cone, using our theorems of cones, and the volume of the small cone, and therefore the frustum is equal to the large cone minus the small cone, which we get 156 pi, or 490.1 centimetres cubed. So that's the first part. Okay, hang on then for the second part, because now, a slightly more difficult thing perhaps, we have to try and find out the surface area of our frustum. Now, the surface area is going to be this curved surface area here, plus the circle at the top, plus the circle at the bottom. Now, let's just annotate that first of all, so we can see what we've got. We know that that length there is 4, that length there is 10, and the height between those was 3. Now, looking at our large cone, we know that the height was 5, and the base radius was 10. And in our small cone, we know that this height was 2, and our radius was 4. Okay, so let's start off by finding out the surface area, the curved surface area of the large cone. So the curved surface area we know is equal to pi times r times L. So r is 10, but what's L? Because this length here is my L. Now you should remember from before, we've got a right angled triangle now, so we know that L squared is equal to 5 squared plus 10 squared, which is 25 plus 100, that's L squared, and so L is equal to the square root of 125. And I'm going to just leave it like that for the moment. So then we're going to put that into our formula. So the surface area is equal to pi times r, which is 10, times the square root of 125. And if we want to neaten it up slightly, that would be 10 pi root 125, or as a decimal number, be 351.2, and they'll both be centimetres squared because we're talking about area here. Let's look at the second one then. So again, this is my dimension L, and so we get L is equal to, or L squared is equal to 4 squared plus 2 squared, so that's 16 plus 4. Put that in and we get 20, and so L is equal to the square root of 20. So the curved surface area, okay, it's pi times r times L, let's just underline that. So it's pi times r, that's 4, times L, which is the square root of 20. Neaten up again, you get 4 pi root 20, or evaluate it as a decimal number, and we get 56.2 centimetres squared. Okay, so let's think about then the surface area of our frustum. So the surface area is the curved part, which we can find by finding out the whole curved surface area of our first one minus the curved surface area of the second one. So when we do that, we get 351.2, that was the larger surface area, minus 56.2. Okay, so that's the curved part. If we want to just annotate that to make sure we understand what that is, that's the curved surface area. Plus we need to add the circle at the top, so that's times pi times 4 squared, plus the circle at the bottom, so that's plus pi, let's just move this 1 minute, times 10 squared. So again, if we just annotate that, that's the top circle, and that's my bottom circle. Okay, if we evaluate each of those parts, we find we get 295, that's the curved surface area, plus 50.3, all these centimetres squared, plus 314.2. When we add all of those up, we find we should get 695.4 centimetres squared. So again, a lot to take in there. Let's just have a quick recap on how we did it. To try and find the surface area of the frustum, we had to find out the surface area of the large cone, and then take away the surface area of the small cone. That just tells us our curved part here. So we do that by using the formula pi RL, okay, and we To be able to find L, we had to use Pythagoras' theorem on a right-angled triangle. So once we've got that, we've got the surface area is pi times r times L for the large, pi times r times L for the small, and do the large, take away the small to find out this part here. Then we have to add on the circle at the top, because that's part of the surface, and then we have to add on the circle at the bottom, because that's also part of the surface. So when we work out those, this curved surface area is 295, top circle is 50.3, bottom circle is 314.2, add those together, and we get our final answer. So loads to take in there. Do have a look over it again if you need to. Well done if you understood all of that.